Thank you, Martin. As the chairman already told, I will shift from milk to beef. Why beef? Because we all know that a reliable performance recording on beef cattle is a basic requirement for the selection, both for selection and extension services, because you can either perform genetic evaluations for all the traits tied to the beef production, and you can even give the farmer a tool for any management decision for the activity, for the profitability of the activity. Sorry. Of course, when we speak about performance recording in beef cattle, what pops up in our mind is the body live weight. That is a key trait for the activity already mentioned. It is normally determined using a scale. That's, I guess, that's clear and normal. But in Italian situation, in the 90s of last century, there was a problem arose in beef performance recording, because there was very small farms, very old breeders, and there was problem in or the breeder didn't possess a scale, or it was difficult for the controller to bring a scale in the farm. And there was a problem even with the calibration of the scales. So it was decided in Italy to allow take a proxy trait instead of for estimating the live weight instead of the live weight itself. And the focus was put on a lot of biometrical measures. And the right candidate to be a proxy trait was the chest circumference that had a high correlation with the body live weight. Because if you, basically the animal is a cylinder, the beef animal is a cylinder. So if you know the area, you can estimate size. So the chest circumference was taken as a proxy trait. And what we do in AIA, we just received the chest girth centimeters and transform them into live weight with a formula that is multiple regression that takes into account the age of the animal at the test day, the centimeters of chest circumference, and the interaction between them. And these formulas are specific for the breed and the sex of the animal. As you see in this picture, but even in this one, the activity of taking the chest circumference has not solved a lot of problems. This guy's name is Paolo, I know him, and he told me that it's not so safe to be in a line of Chianina cows and take chest circumference. You see, he has a stick because he puts on the back and then to collect the tape. So it's not safe for the operator to do this operation, because the animals need to be immobilized, of course. Otherwise, you make a rodeo with the animal. And the risk for the operator is very, very high. So there was a debate in our association on how to go on with the beef performance recording, not touching the animal, but just using a tool that could tell us the chest circumference to, of course, to overcome to these problems. And sorry, but we have to face some constraints. This tool has to be used on free, that is not tied animals, and that to maximize the operator's safeness, of course, and minimize the animal stress, because one of the problems with beef farmers is that when you make a performance recording, you stress the animal, you stress the farmer himself, of course. So it's a good point to minimize the animal stress. Another constraint was that the measures had to be taken in real time and very fast, not being in for an hour to have a look to the animal, to chase him and so on. There would be the need of the accuracy of the measure, because chest circumference is a proxy trait. So if you don't estimate perfectly it, you risk to make a not accurate estimation of the live weight. And there was a need of an ergonomic device, should be shock resistant, waterproof, user friendly, and so on. So you don't need a tank, a truck to have this stuff, but just a handy stuff. The solution was the development of this device was assigned to an engineering study that gave us this solution. The solution was to use a digital camera, a standard digital camera, so you don't touch the animals, just take an image of this. And you can have different distance. If you have the right optics, you can have the right distance for the animal. The stuff should be portable. That is, as already told, not with a truck, but just in a hand, with the free hands and user-friendly. There was another problem, that was the identification of the animal. When we developed this system, the problem of performance recording was split into two phases: the identification of the animal and the estimation of the chest circumference. For the identification, we have a vocal interface. Later, I will show you the functioning. That is talking to the operator. So it's an artificial voice that's talking to the operator and says exactly what to do. And then, last but not least, the system has unmodifiable proofs. That is a watermark on each image it takes with GPS location, hour, date, and animal ID. That is just in case someone would pretend to have performed the control. So there is, as already told, there is a common digital camera with the standard lens. There is an earphone. There is a laser beam projector just connected to the camera. That is this device with the laser beams. These are the laser beams. There is a GPS device, and there is a netbook. I put netbook, it's a laptop or just a portable computer in a backpack with a wire. The netbook, the computer, just perform the software work. Okay. So in this presentation, I split the point of view of the operator and the point of view of the device. From the operator side, the animal is chosen to be measured, say in a paddock. So the animal is put in this paddock. I'm outside, and the animal is identified by the system. How? There is the IDs of the animal of the farm are preloaded. So the system starts to pronounce each ID of the animal. Say it's animal 1, animal 2, animal 3. Say it's 3, you just press a button and the system gets ready for taking the images of animal 3. Okay. I wish it was more clear, but the operator had to point this device with the 2 laser beams just in the position it would put the metric tape, okay? So it just points more or less here. Of course, the operator is supposed to know what it's doing. So he would not take this measure, but should point in this position and in this position, okay? Synthetic voice asks the operator to start taking pictures. So starts with this side's image. You just shoot, and then the system say, okay, I'm done. So you have to start with the front image. You take shoots up to the warning of the system. Say, okay, stop. I have sufficient information. Then the system, the software performs the calculation, the estimation of the chest girth, and then gets ready for another animal. So this is just what the operator should do, that we try to make a more handy and more user-friendly as possible this system. From the device side, what happens? The laser beams are projecting on this point, okay? The system of the camera just identifies these points and interpolate the measure. When the system say shoot, the images are taken and are transferred to the software. What happens in the software? The software just processes the side images and the front images. More precisely, the image processing consists in an edge enhancement. Here is not so clear, but the edge enhancement is necessary to take the right measure. Then there is the color elimination, and then this image is given to the dedicated software that makes, as you see the red line, the measure estimation. So what is really that satisfies us is that all these operations are automatically performed by the software. So you had not to look for the set point. The system just go by himself, and that's it. Practically speaking, the chest girth is an ellipse. The system calculates the major and minor axis of the ellipse, and make with a proprietary algorithm calculates the ellipse. That is the chest girth, the estimated chest girth of the animal. How come? It takes it's a convergence criterion, for successive estimation of the axis. When the criterion is met, it stops. Then it takes the axis, and then there is the calculation of the ellipse. So the calculation of the ellipse is performed. The system just starts to be ready for another estimation. So the picture are stored in the computer, and as already told, the watermarked. So this is in some cases the GPS location is a good indicator of the work of the operator. Okay. The animal is watermarked, date and time. So you can say I was there last Wednesday. There is no possibility to modify the watermarked information on the photo. We are making a lot of field experiences now. We are focusing on the animal identification and on the correct estimation of the chest girth. To what we found in some trials, we found a very low difference between the estimated chest girth and the real chest girth taken with the tape. Just to put some numbers on the table, we went to 2 farms and with four breeds, and took these animals and just take the taped chest girth, that is the regular chest girth, and the estimated chest girth. As you see, except some case, there is this is 205, 202, 6, 204 and 5, 204 and 8, 202, 202.5. So the system shows to be very accurate in estimating the chest girth. The mean of in this trial, the mean difference was 0.16%. The difference, the average difference between estimated and real chest girth was 0.016%. So, to our opinion, is quite satisfying. I already told this. So, which are the advantages? Why we are pushing on this system? Because it shows to be an handy and ergonomic device. In our opinion, should have an accessible price to be disseminated in regular activity, because it has a few simple rules to be followed. There is a maximum operator safety, so Paolo will be happy with this, I guess. There is a fast recording. There is a georeference images that are uneditable. And last but not least, it can create a multimedia database that is available for further research and developments. That is, if you want to develop a formula with the chest girth and wither height and legs length and so on, we can study on these images and can improve the estimation, or we can have some other hints to study. I patented this device, and for the next future will be a software downsizing. Actually, the software is the critical part of the system. Will be put in Linux operating system, even in Android operating system, that in our opinion could allow to use just a smartphone for making a performance recording BIF. So we are very confident in this device, and we will for sure do our best to make it a precise and reliable tool. Thank you.
Thank you, Mauro.